Now, my talk will be a lot about the separation between the technology and the architecture. And I will start with the technology. And to do that, I will go back a little bit, and I will talk about the web in general, because I think all of us will agree that the web is great, right? We have this global network of servers. They're all connected with each other. They're all talking to each other. We have standardized languages, scripting languages, like JavaScript, CSS, HTML, and all across different devices, different browsers, different operating systems. They're standardized, and we have the URL system, where each piece of content has one unique identifier, which could be a video, could be a blog post, an image, doesn't matter. We have one unique identifier. And if you think about that, that's awesome, right? Well, then we have this other thing called apps. And apps are cool as well, because we can use the full potential of our device. We can write expensive tasks. We can maybe do some very cool animations and everything. But in the end, we do have to write exactly the same application multiple times. We have it maybe for iOS, we have it for Android, we have it for Windows desktop, we have it for Mac OS, so at least we have to write it 4 times, maybe even Linux. There's also another operating system. And that's insane. If you compare it to the web, where you have one application, and that works for everything. So why would anyone do that? Why would anyone write native apps if we have the web? I can tell you why. It's because of the users. 87% of the time the user spends on his smartphone, he is inside native apps. And that's huge, because that means in the end, all of us, everyone who is somehow connected to the web, somehow writing content for the web or writing web applications, we all need to share the remaining 15%. 87% is taken by native applications. Luckily, there were some people at Google. They were thinking about why are native apps so much more popular than web applications. And they figured out 4 words. Native applications are fast, because once you've downloaded them, everything is already on your device. So they can boot up immediately without, or in theory, without any network request. Everything is on your phone, you can just boot up. They are integrated. Why is that important? I like to compare it to the living room. Living room is a place where you have limited space, so you have a limited amount of items, of things you can work with, you can play with, but that feels inside your comfort zone, right? The smartphone is exactly the same. You have a limited amount of space for your apps, and all of those apps, they feel integrated, they feel like in your comfort zone. Then you have the door or the window or whatever where you can go outside and you have the whole world in front of you. You have the browsers, but it doesn't feel like in your comfort zone. It doesn't feel integrated. That's why it's important. They are reliable. Even if you don't have any internet connection or a bad internet connection, you still have something on your device. So if you click on the app icon, you will have something. Maybe it's not the latest content because you don't have any internet connection, but at least you will have, well, let's say at least you have an error message or something like that. And they are engaging. So you can send push notifications, so you can re-engage your users to use your application. So they were thinking about a next generation of web applications, and they were calling it progressive web apps. That's it. So in the end, the question, what is a progressive web app? It seems like a very easy question, but I've seen so many, let's say, wrong or misunderstood definitions of progressive web apps. In the end, A progressive web app is just a website. It's not something between a website and a native app. It's a website. It's HTML, CSS, JavaScript. It runs inside the browser. Here we are, it's a website. But there are some new features, so I call it a website plus. What are those features? First, we have the manifest. One thing first, I really like to show something with my hands, but since that's a pretty big screen, I need to rely on that thing. Here we are. Yeah. So we have the website from Smashing Magazine, which is a progressive web app, and they are using a web app manifest. In the end, the web app manifest is just a little JSON file which contains information about your app. You can register it using one little attribute in your head, and then you have the JSON file which contains things like the name of your app, description of your app. You have a start URL, which also defines the scope of that manifest file. You have icons, like little. You can set a whole bunch of icons, and the browser will then choose which one is best for him. And then the browser can ask you, or he detects, well, that's a progressive web app, and he asks you, do you want to add that to your home screen? I know at the moment, since Chrome 68, it's a little smaller, but there's still this add to home screen banner. If you click on that, it will add your progressive web app to your home screen, right here, right next to all the other native apps. Now, if you open it, it will open in a new display mode. The display mode is defined here. Display standalone. Standalone means that it takes the full screen except the notification bar. You can also set it without the notification bar, but it will open in that specific display mode. And even then, if you open the task manager, you will find your progressive web app next to all the other apps, and even next to Google Chrome. And that's interesting because Google Chrome actually still powers a progressive web app. I said it's a website, just another display mode. But that's the cool thing with the web app manifest. Now we have something else, which is the service worker. If we take our website, here it's Wikipedia, we have JavaScript. And JavaScript has become a very powerful scripting or programming language, depends on how you define it. But JavaScript has one big problem. It controls your website, and as soon as you close it, it's dead, right? You can do amazing stuff just with JavaScript, but as soon as you close the website or the browser, there are no events anymore, you can't listen to anything, it's done. The service worker now is also a JavaScript file, but it lives in a different scope. It lives somewhere between the website and the browser and the application, and the cool thing is it lives there forever. So even if you close the website, even if you close the browser, it's still running, it's still listening to events, and we can work with that. How does that look? It's pretty easy to integrate. It's also just one navigator service worker register function. Then you have the service worker, and you can also give a scope. And if the browser detects that, that's one service worker that then controls the whole scope you define. It controls the website under that scope. As I said, it's just a JavaScript file, so we have listeners, event listeners, we have the install event, which is fired as soon as the browser detects a progressive web app, or a service worker, sorry. We have the activate event if all the installation is done, and we have then the fetch event as another example, where it listens to outgoing and incoming network requests. And one other cool thing is, as far as I know, every browser that supports service workers also supports ES6. So you can use ES6 syntax without any Babel or any bundling or anything like that. That's the whole magic. So how can we make a website reliable? We still have our website, and that's perfect because we have a network request, it comes back, browser displays a response, we're good. If we don't have any internet connection, it will fail. We'll get an error message. In our case, that's the dinosaur, and the browser has nothing to display, so he just gets an error message. With the service worker, we have now something sitting between the network, between the website and the internet. And yes, I do like to think about my service worker as a little construction worker. And it sits there and it communicates with a new thing called the application storage. So now, if we don't have any internet connection, we still have a reliable source. We still have the application storage, and the service worker can then decide where should it take the content from the internet or from the application storage. In our case here, we have some sort of a network-first strategy, where the browser first checks if we have an internet connection. If yes, it takes the response, displays it on the website, and it puts a copy inside the application storage. If we don't have an internet connection, it just takes the already stored version from the application storage, and we still have a reliable source. So having no internet it's pretty bad, but we do have a fallback solution with a service worker, and having no internet connection is not the worst thing. When I prepared those slides, I was in Italy on a camping site. And, it was still in Europe. It was 2018, so I did not have no internet. I had Wi-Fi. I had camping site Wi-Fi, which is sometimes better, sometimes nothing, normally on a stable minimum. And that's the real pain of using the internet, because having no internet connection is honest. You don't have any connection, you get an error message. Simple. Having that kind of flaky or unstable internet connection, there's one very cool term by Jake Archibald. He calls that Li-Fi. Because you think you have internet connection. You see the little bar, but your app will load and load and load. You will see a white screen with a loader. Eventually, some seconds later, you think, yeah, just 1 second more, but you won't get any response. So one time it will fail, could be seconds, could be minutes. So that's the real pain of using the internet in 2018 or 19. What can we do about that? We can make our website faster using the application storage. In that case, we have the same scheme as before, but in that case, our service worker will look inside the application storage first. If he finds the request there already, he will just take the cache version. It will be returned immediately because it's on your device already. And if it has if the request is not already in the application storage, it will fall back to the network and we'll get the most recent. The cool thing is, we can decide for each request, we can decide which strategy we want to take. We can say, okay, for JSON files and HTML files, dynamic files, we will take a network-first strategy where we'll have the most recent content. And for static files like images, CSS files, JavaScript files, we will just take a cache-first strategy. So those static files are on your device already. And for the rest, we have the network. Last thing is engaging. There is the web notification API. It's been around for I think it's in Chrome, it's around for some years. And the web notification API lets you display push notifications from the browser. And that's cool, but as we've seen before, as soon as you close the website, the JavaScript won't work anymore. So it doesn't make sense to show someone a push notification that is actually at the moment on your website, right? That is active on your website. So the web notification API makes sense since we have the service worker. Because there we have the messaging service and the service worker and the web app. And we can register a push notification endpoint by using the public and the private key over a messaging system that will create a endpoint, and that endpoint can be triggered by the messaging service. The service worker will receive that push, and he will display the push message on your device, even if your website or even if the browser is closed. That's a very cool feature because it allows, well, for most websites it doesn't make sense to show this push notifications, right? But for some cases, let's take email clients, let's take Twitter. For them, being able to show push notification is a crucial part of their user experience. So it is a very important feature, but it's also very powerful. And with great power comes great responsibility. Who knows what that is? That's a browser permission request. And it's not just an extension of your user interface. So how do you feel about them? Probably a little bit like that, because lately I've seen so many websites that are misusing that permission request. You really think about it as a permission request, like the camera or a GPS, a geolocation. So you would never ask for camera access right on the first page load, right? Never. But for push notifications, it somehow seems legit. It isn't. If you want to use push notifications, you should really think about when, about how, and about why you need to ask for that specific request. So we do have our progressive web app. It's fast because we have content from the application storage. It's integrated, we add it to our home screen. It's reliable because you have network-first caching, and it's engaging because you can send push notifications. Cool. The second part is the architecture. When the whole internet started, we had the hypertext family. We had HTML documents, and you could create a contact HTML, you would put it on your server, and the browser would then take that HTML document, display it. Cool. We have a static site, and if you want to change something, we need to go inside that HTML document, we can change it there, upload it, and we have an updated version. But what if we have, let's say, 5, 6, 7 or more websites with the same footer, and we want to change something somewhere in the footer? We would need to go through all HTML documents, change it there, and upload it again. Luckily, they are dynamic sites, multi-page applications. We have server-side scripting languages. In our case, it's PHP. And we can send a request with some parameters, and the server then builds our website with those parameters. So it's dynamic, rendered on the server. And then we have the new kid on the block, single-page applications. And they're cool because the whole rendering takes place inside the browser. So you would have that index HTML file together with some JavaScript, and the browser then builds the whole website. And the cool thing there is it's reactive. And also, new is always better. And I know single-page applications are cool because you can send very small changes, very small requests, only like a little container that will change. You don't have to make a full document DOM reload, and you have the separation between the front end and the back end. They are very cool. But in the end, there are some downsides of single-page applications. First, the content is loaded asynchronously. So on the initial request, you don't have any actual content. It will be loaded afterwards, normally. The whole workload is on a device. For flagship phones, it's no problem, even for, well, not that expensive phones as well, but you still need to have JavaScript enabled, and you need to support a whole bunch of devices, because the whole processing takes place on the device. So you have hundreds of devices you need to cover, different browsers you need to cover. So in the end, you will use a framework. And I know you can create workarounds using server-side rendering for JavaScript for all of that, but there's one thing you can't deny. Single-page applications are quite expensive to build because you need to have the whole development workflow, you need to have the whole building process or inside your development workflow. So maybe it's not the best thing for all websites to have single-page applications. There is still some cool use cases for multi-page applications. Now let's put that all together. We have us awesome PWAs, sorry. We have Twitter Lite, which is a web version of Twitter. It has around the same possibilities as the native Twitter app. We have Pinterest, which is a very small version, and actually that's their main website is a progressive web app. We have this Mastering magazine, as you have seen before, and we have a new app from Starbucks, which is a progressive web app, and they are awesome. They're very, very cool progressive web applications, but they have one thing in common. Those are websites of huge companies, with a lot of developer power, a lot of money behind that. And when I first heard about progressive web apps, I was a little bit afraid that that would be just some very cool thing for those who can afford it. Turns out it's not. Let's go back to our scheme we've seen before, where we have the service worker controlling our website. In the end, it just doesn't matter. That could be a single-page application, but that could also be the front end of a content management system, as WordPress, Drupal, Joomla, Craft, you name it. So it works also. It doesn't matter what architecture is there behind the progressive web app functionalities. And when I realized that, I created our own website as a progressive web app. So that's a normal multi-page application. Actually, it's a WordPress website, and I've added those features, so it's now installable, it works offline, and you can receive push notifications. As you can see here, it's a very decent option in the footer. So you can click there, and then it will ask you if you want to. So it's not upfront. That's possible. But there are some little things I had to keep in mind. First thing, who knows what the app shell model is? Okay, the app shell model is for single-page applications where you have the index HTML file, you have some stylings, you have some JavaScript and some images, and that's basically the shell around your content. And with single-page applications, you can take those files, you can put it in the application storage, so they're there on your device all time. So you have something you can work with even if you don't have any internet connection. With multi-page applications, you don't have an app shell because every website is fully DOM document. But what you can do is you can pre-cache some sites. What I did is I had the front page, I had the offline, I created an offline page, some styles, some JavaScript, and some images. And I just, instead of having just a little app shell inside my application storage, I have the full HTML sites inside my application storage. Then there is something else. I've said before that the service worker is just a JavaScript file, the manifest is just a JSON file, and I was thinking, or let's say in my first version, I had those files as static files in the root of my WordPress installation. And that worked for me, but I figured out that if you have different server configurations, that might cause problems, because if it fails to regenerate those files on the save of your options maybe, you don't have a service worker or a manifest file. And then again, I was thinking, well, I have a dynamic website. It's all rendered on the server. Why couldn't be the manifest file and the service worker also be rendered? So what I have now is a dynamic service worker and a dynamic manifest file that will be built on each request, let's say on the runtime, let's say. So the last thing, progressive web apps and content management system, they work together pretty good. One little question, if you take the last 6 months, who of you did work with WordPress as a developer, content creator, whatever? Quite a few. And for those who didn't show their hand, who was just too afraid to show anyone that he had to work with WordPress? Yeah, whoa, there's one. Great. WordPress is a great platform to test new technologies, or not to test, but to enable it to a bigger community. Because it's open source, you can work with it. You have a great community of developers that are already working on some solutions. It's huge. We have, if you take the CMSs, we have more than 50% of all websites use 50% of all CMS websites, and I think 30% of all overall websites use WordPress or are powered by WordPress. And it has a modular architecture. And that's important because you can test something using a plugin. You can test it, and if you think that's cool, that's something for everyone, you can suggest it for the core. So you have that modular architecture, you can test something, and if it's cool, if it's good, you can merge it to the core. And that's what I did. I created a plugin called Progressive WordPress, and it does that. It takes those features, the manifest file and the service worker, and it just adds those features as an add-on enhancement to any existing WordPress website. It's not about WordPress, it's really just about how you can use it with any multi-page application. At the end, that's just the plugin. We have some options. We can change the manifest values right in the CMS. We can choose which page should be on the front page, which page should be displayed if I click on the manifest and on the application icon. I have some settings. I can even set some service worker settings. I can choose different caching strategies for different requests. Right here. And I also can add push notifications using Firebase. So in the end, one very cool thing is WordPress already has a built-in REST API. And since the manifest file is nothing else than a JSON file, I was just able to use a new REST endpoint, or I created a new REST endpoint with all the JSON, with all the web app manifest informations. And I also created a new query with a service worker. And to make it future-proof, I added a little scope option. So the idea was I could create different scopes by just changing the key, let's say, inside my request. So I have those files, and they are dynamic. They are rendered on the request. So it works, and it's cool. And the best thing is, it works all the time, let's say. But there's one problem with modular progressive web apps. If you take WordPress, where we have themes and plugins, and also Drupal and Typo 3, where we have some closed modules that add features to your website, we will have conflicts with using progressive web apps. Because there can only be one manifest per website. If you have my plugin, let's say, and we have a theme that also has some manifest values, and they both try to register their manifest, that won't work. So there can only be one manifest file per website. Also the service worker. I was talking about the scope, and each website can only be controlled by one service worker. So if you try to register 2 service workers for one scope, that won't work as well. So in the end, when I created my plugin, it was the first progressive web app plugin, the first fully featured progressive web app plugin. But with the time, we have more and more plugins and themes that are using progressive web app features. And I run in some problems which I described. If this theme uses a manifest file and my plugin uses a manifest file, we have conflicts. Luckily, we are working on a solution. That's a feature plugin, which means that that plugin contains features and code that is proposed or that will be part of the WordPress core in the future. It's supported by, or it's created by XWP and supported by Google and also by me. I also did some commits to the code. And the idea here is to provide standardized APIs. We have a manifest API, so you don't have to register your own manifest file, but you can use the API to add your values to the manifest. We have a service worker API where you have where you can add code to the service worker. We also have a PHP abstraction of Workbox. Workbox is a JavaScript library for, well, that creates an overlay over the fetch event, so it's really easy using Workbox to add different caching strategies. And in the end, as I said, it's not about WordPress, it's about every CMS, because progressive web apps are a really big thing. And they are coming in the future. As soon as we have full browser support for all features, we will have what I call a progressive web app revolution. And your framework or your content management system, whatever, you need to make sure that your system is ready for those changes. So to wrap it up, first thing I want you to take with you is progressive web apps, or the technology. It's a technology. It's not a product. It's just a technology, and you can use it with different types of websites, types of web applications. The second thing is it can improve everyone's website. And I'm not talking about, well, each blog should look and feel like an app, and everyone comes and, hey, look, I have created an app, which is just a WordPress website with a manifest file. In the end, it's about having a service worker being able to have a controllable cache, and to minimize network requests. So it can improve everyone's website, not just the big Twitter Lite or Starbucks or whatever. And you need to keep an eye on the CMS integration, because if I'm not sure if that's it's already, or as far as I know, WordPress is the only CMS that is working on a solution to add progressive web app APIs. But you need to keep an eye on your CMS, what they are doing, and if they're doing nothing, you should do something about that, because it's important. So that's it from my side. Thank you very much for your attention. And if you have any questions, I think we still have some time.
Actually, we do. Is there any questions for Nico? You want the mic?
Which artists when you develop this? So I know Lighthouse.
Well, Lighthouse is a great tool, but in the end, if you want to make sure that your features are working, you just need to test them on different devices. I did not talk a lot about browser capabilities, but at the moment it's fully supported in Chrome. There is support on iOS, on Chrome, on Android, I need to say. There's some support on iOS, but you don't have an install prompt, for example. You can use push notifications because the web notification API is not ready in iOS yet. But in the end, you just need to test it. And what I do is I use the dev tools in Google Chrome. There you can see is my, I can show it if you want to. If you take the demo site, which is just the 2017 theme, if you open the console, you have this application tab, and there you can see what's the web app manifest. What are the features or the values Chrome detects? You have the service worker, where you can see, okay, that's the service worker that is controlling my site right now. And you also have the storage, where you have the different things. Let's take fonts, should be empty. Here, the default storage, where you have the main page is stored inside my my application storage, and you can just look at the DevTools and you can see what's happening on your site, on your progressive web app.
We still have time.
Yeah.
Right there, you register script in the header. Is there any upside to that?
Sorry?
Right there on line around, yeah, there, down, where meta name generator and underneath it, if service worker in navigator. Is there any upside to that, or?
Well, you still have service browsers that don't support service workers. So if we make that feature check here, we make sure that we only apply the registration for those browsers who support it. What I did here is, that's my plugin, and as I said before, I had the static file, which was pwp minus serviceworker.js, and what I did then is, when I changed to the new system where I have dynamic service workers, I created a little unregistered script, what you see here. So I just wanted to make sure that the old script was unregistered before I registered my new script, which you can see there below. Yes?
Sorry.
So since we have now an app on the phone that you can click on it, my question will be, what are the possibilities that you have for interacting with the hardware of the phone itself?
With the hardware,
For gyroscope, for cell tower, for triangulation, stuff like that.
Sorry?
For gyroscope, for whatever.
The thing is,
part.
we still have a website. It's nothing special. So when I open it, it's still Chrome in the background that powers my progressive web app. So I don't have any more, I didn't have any problems which wouldn't be, or also in the Chrome version of my progressive web app. So in the background, I'm using Chrome. It's the browser that displays my website, and I don't have any. I didn't have any more problems with the hardware, because the hardware is all controlled by the browser. Or have you been talking about the back button or button?
No, the question is more because since now you have something on your home screen, right? The expectation for the user might be that it's more integrated into the phone itself, like a native app, right? Then you would have an expectation that it could do stuff with the hardware, and then the user experience might deteriorate because of that.
Okay. The thing is, for a user perspective, it should feel like a native app. That's the whole idea. So even if for us, for a developer, it's clear that we don't have a native app, but for the user, he doesn't care if it's a native app or it's a web app. You can just simulate a web app. I mean, if you take 20 Minuten or Blick, those are native apps. But in the end, they don't do much more than just, well, displaying web content. And the progressive web app does exactly that. They take away that wrapper a 20-minute or Blick might have, and they just say, well, we have that wrapper, that's a browser, and we will just use the browser as a native app wrapper. I don't think that the user should care about what's under the hood.
That was a bit controversial, but sure. We have time for one more question. We have actually 3 minutes.
How do you handle IndexedDB inside of your
Sorry?
plugin? How do you handle IndexedDB? Offline
Not yet.
synchronization. Okay.
It makes sense for single-page applications because there you have raw content you could put inside IndexedDB. But as we are talking about multi-page applications, we have the full request, we have the full document object model. And we can just put it inside the application storage, and we don't need to have, or maybe there are some, let's say if you want to have offline content, and then, well, if you have, let's say, a comment form, and you want to store it there, and you want to sync it afterwards, you might use the IndexedDB. But with multi-page applications where you don't have any raw data, you can just use the application storage. In my opinion, that's enough. Yeah.
I think we still got a minute.
Okay.
Melt this.
So my question is, how much data can you store in the application storage, and is it standardized across devices, browsers, and also does it change if you add it to your home screen?
Yeah. One thing, it does not change if you add it to your home screen. And that's one very important misunderstanding. The service worker gets registered if you visit the website, and it doesn't matter if you install it, like put it on your home screen or not. I don't have it on my home screen, but the service worker is still running, and you still have the application storage. The first question is a very good question, and that's one question I get asked every time I have a talk about Progressive Web App, and the answer is, well, there is no standard. It depends on the device. It depends on how the device splits the space between applications, and then it depends on how the application, Chrome, splits the space between the Progressive Web Apps. I think that will become a problem if we have more Progressive Web Apps, more websites that use the service worker and application storage. But at the moment, I don't think, or I have not seen any standardization about how much space you can use. Well, I would not put a video in there, of course. But, well, if you have some HTML, some CSS, even maybe some images, I don't think you will have any problems.
Okay, thank you so much, Nico.
Thank you.
So we can applaud him again, please. This is